Hi everyone, today our students will explain Prim's algorithm in case study based. This case study focuses on understanding how Prim's algorithm can be applied to solve real world network design problems. In many practical situations such as connecting cities, computers or communication system, it is important to create connection while minimizing overall cost. These problems can be modeled using graphs in the field of graph theory, where locations are represented as node and connection as weighted edge. The goal is to identify a minimum spanning tree that links all nodes with the least total weight. Through this case study, we explore how Prim's algorithm provides an efficient and systematic solution to such networks optimization problem. Further, we'll explain Arati.
Today we are going to present a case study explaining how Prim's algorithm can be used to solve real-world network design problems. Imagine a situation where a government plans to connect multiple cities with a road network. Each road requires construction cost, and naturally the government wants to minimize this total cost while still connecting all cities. Similarly, in computer networks, companies often need to connect multiple computers, servers or office using cables. The goal is the same: connect all locations while using the least amount of resources. To represent such systems, computer scientists use graphs. In graph theory, vertices, edges, weights. Vertices means it represents locations such as cities or computers, and edges represent connections between them. Weights represent the cost, distance or time of those connections. However, connecting every possible pairs of nodes would like to be extremely expensive and unnecessary. So the challenge becomes, how can we connect all nodes efficiently and economically? To solve this type of problems, we use a concept called the minimum spanning tree, which ensures all the nodes are connected to the minimum cost connection cost. One of the algorithm used to find the solution is Prim's algorithm. Further will explained by Saistri.
So in this case study, the main problem is designing an efficient network. So when connecting multiple locations, we must ensure three things. Every location is connected, there are no unnecessary loops or cycles, the total cost of connections is minimal. So this requirement leads to the concept of minimum spanning tree, commonly called as MST. A spanning tree is a structure that connects all vertices in a graph using a subset of edges. It has two important characteristics. It connects all vertices and it contains no cycles. So in a graph has b vertices, a spanning tree will contain exactly b minus 1 edges. However, there can be many possible spanning trees for a graph. Among them, we select the one with the lowest total edge weight, which becomes the minimum spanning tree. So this ensures that the network remains fully connected but uses the least possible cost. Several algorithms exist to find a minimum spanning tree. Some of the most popular ones are Prim's algorithm and Kruskal's algorithm. So in our case study, we focus on Prim's algorithm, which builds the network step by step.
Prim's greedy algorithm used to find the minimum spanning tree of a weighted graph. The term greedy means that the algorithm makes the best possible choice at each step. Instead of building the entire network at once, Prim's algorithm gradually expands the network by selecting the smallest possible connection. The algorithm begins by selecting any one vertex as the starting point. From the starting point, it examines all the edges connected to the vertex and selects the edge with the smallest weight. This edge connects the new vertex to the growing network. Once the new vertex is added, the algorithm again checks all the edges connected the existing network to the remaining vertices. Among those edges, the algorithm selects the minimum weight edge and adds it to the tree. This process continues step by step, gradually expanding the network. Two important rules are always followed. The algorithm always chooses the minimum cost edge. It avoids forming cycles by repeating this process until all the vertices are equal. This algorithm forms a minimum spanning tree. This approach ensures that the final network is both fully connected and cost efficient.
Now let us briefly discuss how Prim's algorithm is implemented in computer system. The algorithm starts by selecting the starting vertex and making it as the part of the spanning tree. Then it repeatedly searches for the minimum weight edge that connects a vertex in the tree to a vertex outside the tree. One such an example edges is found, it is added to the tree and then connected vertex becomes part of the network. This process continues until all vertices in the graph are removed. To perform this efficiency, certain data structures are used such as adjacency matrix, priority queues, memory. These structures help the algorithm quickly find the smallest edge available at each step. The performance of Prim's algorithm depends on the implementation. With a simple adjacency matrix, the time complexity is O of V square. With advanced structures such as priority queues, the complexity improves to order of E log V. Because of the efficiency, Prim's algorithm is widely used in large-scale network planning problems.
Plays an important role in solving real-world infrastructure and network problems. In our case study, we saw how it helped design of cost-efficient road or communication network. Same major application includes network computer networks. Prim's algorithm help design network connection, computers and server while minimum cable length. Road and transportation system. Cities planner use similar principle when designing the road network connection, multiple location. Electrical power distribution. Power companies use these concepts when the designing writing system then connect the power station to cities. Telecommunication networks. It also useful in the planning fiber optimization cable networks between the communication towers. The biggest advantages of Prim's algorithm is that it provides systematic and efficient way to connect the multiple locations with minimum cost. To conclude this case study, Prim's algorithm is an important algorithm in graph theory that help solve the real-world network design the problem. To gradually building a network using the smallest available networks, it ensures that the final system is finally connected efficient and cost efficiently. Thank you.